Hello viewers, my name is Mr. Kazim and I am delighted to welcome you to my YouTube channel at Smart Edu TV. Here you will find detailed tutorials on your science courses and tips on how to answer examination questions successfully. I started this channel to also share my knowledge and experience in this field and to give you tips on how to succeed as a university student. If you are looking for detailed tutorials on physics subjects, chemistry, mathematics, biology, statistics, and general studies (GST), then you have come to the right channel. So therefore, sit back, relax, and join me on this journey. Don't forget to hit the subscribe button and turn on the notification bell to never miss on an important update. Please remember to also share this video so that others can benefit. Thank you very much. Okay, welcome back. The next we are going to look at is, we've seen what happens to time. So the next we are going to look at under the kinematics of projectile motion is distance. Let's also see what happens towards distance. Also, we are going to be looking at distance in what? In two dimensions. That is, what happens to the distance at the maximum height, and also the second dimension, what happens to the distance at the what? The duration of that period. At the duration of that projectile motion. That is at the horizontal distance. So now we are going to start with the first one. We want to see what happens to the distance at the maximum height. Number 2, distance. So let's see what happens to distance at what? At maximum height. At maximum height, let's see so that we can understand it better. This is my y-axis, this is my what? X-axis. This is my projectile motion. At maximum height, at this point, when what? The height is what? Maximum. At maximum height, you can see this shows that what? This is the highest point of that projectile motion. So here, at maximum height, I will notice that at this point, this is what? The peak of that projectile motion. It means my velocity at this point along the y-axis is equal to what? 0. There is no more what? Velocity along that what? Y-axis. There is no velocity along the what? Y-axis. So because of that, so I'm not going to check again inside my what? Equations of motion. The equation that relates the velocity to the what? Height. The velocity to the what? Height. I want to see the equation that relates the velocity to the what? Maximum height. In my equation of motion, the only equation that relates the velocity to the what? Height is v squared equals u squared plus 2as. It relates velocity to the what? Height or distance. Either you call it height or you call it what? Distance. They mean what? The same thing. So v squared equals what? U squared plus 2as. So if I want to what? Write this very well. Noting that at the y-axis, the velocity is what? 0. Also, our u along the what? Y-axis we what? Sine. It is what? Sine theta. And our a becomes what? Minus g, because it is going against what? Gravity. So therefore, we can rewrite that equation very well. That is our vy squared, or let's say vy, which is what? Since we know that is what is 0, equals u squared. Our u along the what? Y-axis becomes what? U sine theta. U squared plus 2as. The a becomes what? Minus g, because it is going against gravity. Minus what? G. Minus what? 2g. The s is now what? Our h, which is what? Our height, which is what? Maximum. H maximum. H maximum, which is maximum height. So therefore, since our velocity along the y-axis is what? Is 0. This can still be written as 0 equals u sine theta all squared minus 2g h max. This can also be further written clearly as 0 equals, if I open up this bracket, u squared sine squared theta or sine theta all squared, they still mean the same thing. U squared sine squared theta minus 2g h max, where this is what the maximum height. So that if this comes to the other side, the minus sign becomes positive. So that we have 2gh max. 2gh max equals u squared sine squared theta. From here, we can have our maximum height h max to be equal to what? U squared sine squared theta over 2g. U squared sine squared theta over what? 2g. This is the expression that gives what? The maximum height for an object undergoing a projectile motion. So we've seen what happened to the distance at what? As maximum height. The second dimension we are going to look at what distance from is, we want to see what happens to this distance at the horizontal distance. We want to see what happened to this distance along the what? Along the horizontal. So that we want to see what happens to distance along the what? Horizontal. So what happens to the distance along the horizontal axis is also called what? Range. The range of what? Projection. That is the horizontal distance. The range of what? Projection. For us to what? Understand what the range is what is talking about, it means we have to look at it in terms of what? Velocity. That is our range. Don't forget, our range is what? Is the horizontal distance of a body that is undergoing what? A projectile motion. We want to see what happens what to the what? Velocity. Its velocity v equals distance of displacement over what? Time. Since we are talking about what? Horizontal distance, I'm expected to the velocity to be what? The velocity along the x-axis. Since I'm talking about the horizontal distance, not velocity along the what? Y-axis. Since I know that velocity along the y-axis equals what? 0. So that my px will now be equal to what? That displacement or distance. That horizontal displacement or distance, let me call it what? Range. Which is what? R. Let R denote what? Range or horizontal distance or displacement. Which is what? R over what? Time. Which is what? T. That means we are looking at what? The velocity as what? Along the horizontal axis, which is what? Equal to what? The range over what? The time. That is the total time that object takes. The total time that object that is undergoing a projectile motion takes from the starting point to the what? Stopping point. So Vx equals R over what? T. If that is the case, I can write this as, if I cross multiply, my range R can be equal to what? Vx multiplied by what? T. Where this T is the time of flight of that projectile motion. So here we can have our range to be equal to, what is velocity along the what? X-axis. Velocity along the x-axis is given as what? U cos theta. Multiplying our time of flight. Our time of flight is given as 2u sin theta over g. Don't forget. Our time of flight is given as 2u sin theta over what? G. Multiplying 2u sin theta over what? G. So that if you look at the two of them, I can combine them as range R to be equal to, look at this, there's G here, there's another G here, I can have what? U squared. I'll pick this U, I'll pick this, so I'm left with what? 2 multiplying what? Sin theta and cos theta. Multiply by what? 2 sin theta cos theta. Everything divided by what? G. Everything divided by what? G. So that if I clean this, I'm going to have my range to be equal to U squared 2 sin theta cos theta over what? G. But according to trigonometry, according to what? Trigonometry, So this is what 2 theta. This is 2 theta. So sine 2 theta equals 2 sine theta cos theta. So that r equals to what? U squared sine 2 theta over what? G. At maximum range, when theta is what? 45 degrees, our r equals to what? U squared over what? G. And this is the formula for obtaining the maximum range of an object that is undergoing a projectile motion. Thank you.